All right, so let's talk about our sum to product or product to sum identities. As before, we're going to derive one of these things. So let's start with the sine of alpha plus beta and then add it to the sine of alpha minus beta. And all we're going to do really easily is just apply the sum and difference identities for sine. So when we do that, we end up getting this big long thing right here, which if you recognize cosine alpha sine beta, and then we have a negative cosine alpha sine beta, so those are going to cancel out. And then we're left with the sine alpha cosine beta. We actually have two of those. So that simplifies down to 2 sine alpha cosine beta. So what this does is it allows us to take a product, something like this, and rewrite it as a sum of alpha plus beta and alpha minus beta. So here are the 4 product to sum identities. And if you had to derive any one of these, you would just start off with whatever expression you have over here, and you'll create that expression over there. Okay, I know these are rather complicated, trying to remember them all, but they're pretty easy to use. All right, so this is great if you have a product, something like this, and even you don't have to have the 2 because you could divide through and say this is 1/2 of this whole thing, right? So if you have a product of a sine and a cosine, you can rewrite it as a sum or difference. So what if we wanted to go the other way? What if we had a sum or difference and we wanted to write it as a product, but we didn't have our angles broken up as alpha and beta? Well, we're going to create these alternate forms. So I'm going to start off with that first product to sum identity that we had here, and I'm going to find 2 numbers that add to be s and subtract to be t. So I'm introducing these new variables, and those 2 numbers that we're going to talk about are alpha and beta. So if I let s equal to the sum of alpha plus beta, and t represent the difference of alpha minus beta, what I can do with these 2 equations is I actually can add them together, and that eliminates beta. So when I add them together, I get s plus t over 2 is equal to alpha. And then if I subtract them, that's going to eliminate the alpha, and so I get s minus t over 2 is equal to beta. So now what I can do is I can take this expression, the alpha plus beta, and replace it with s. So right there, this will turn into an s. Take alpha minus beta, replace it with t, so this is going to turn into t. And then this alpha and this beta are going to get replaced with these 2 expressions. So when all of this gets plugged into this identity, and I'm just going to show all of them for you, but this first one right here, this is the sine of s plus the sine of t is equal to the, here's the 2, the sine of alpha, which is s plus t over 2, times the cosine, and there's beta right there is s minus t over 2. So what this does is now if I had, the sine of 20 plus the sine of 30, I can add those together and it comes out to be a product, and using the 20 and the 30 you can figure out what these 2 new angles would be. So those are very convenient to use when you need to simplify things down later on. So let's see how to apply them. They're really easy to work with. So here's the first one. We're supposed to express this as a sum. So here are the 4 that start off with the product and working towards a sum. So we need to find the right one to use. So this one's the cosine times the sine. So if you look right here, cosine alpha sine beta. So this is the identity that we're going to use. So this is alpha, this is beta. So we're just going to plug those in and simplify. And there you go. That's it. See how easy that is? Okay, what if we needed to use one of the alternate forms? So we are taking a difference or a sum and wanting to express it as a product. Okay, well here are those identities. So we need to find the right one. Cosine minus cosine is right here. So this is the identity that we're going to use. Now I know this has a t in it, so just pretend it has a different variable like x. But this is s, and this is t in this identity. So when we apply it, the first one we're adding them and dividing by 2, and then the second one over here we're subtracting them and dividing by 2. Now we end up getting a negative angle here when we simplify this down. And if that ever happens, we need to deal with it. If you remember the odd-even functions, how sine plays out, the sine of a negative angle is the same as negative sine of the positive angle. So this, it's like pulling out the negative out front. Well, that's going to get combined with that negative. So this solution should be 2 sine t sine 4t. And that's it. Those are your sum product identities. Okay? All right.